Hello, my name is James Davis and I'm a sales engineer here at SolarWinds. In this guided product tour, I will review key aspects of the SolarWinds Database Performance Analyzer, also known as DPA. DPA changes the way teams manage and improve application and database performance. By putting the focus on application end-user wait time, you can quickly deliver performance improvements that get noticed. Database performance is a major contributor to slow application response time. In this video, you will see how DPA, in just 4 clicks, can drill down to the root cause of performance problems, see historical trends, and get expert advice. DPA gives your team 24/7 monitoring, performance analysis, and alerting of critical issues. DPA utilizes a unique response time analysis methodology, which focuses on the time between a query request and a response from the database. DPA analyzes wait types and events to identify key bottlenecks. Once logged in, we'll start at the home screen. This page will give you a great overview of where the major trouble spots are. You can drill into the summary alarms to isolate your view of any issues. Sort and click into any of the resources to quickly investigate a problem. Let's start by clicking on a database instance. Here in the trend dashboard, the bars represent the total time application users wait over the course of a month. By default, we show the top 15 SQL statements based on the wait time over a 30-day period. With the reporting feature, you can access up to 5 years of history. Each color seen here represents a unique SQL statement. You can see more detail by hovering over the bars. The radio buttons in the upper left corner display different views of these SQL statements. Clicking on the average wait button shows the longest running top 15 SQL statements by day. Looking at this view, we can see that September 4th had more wait on average than other days. Let's drill into this day to see more detail. Drilling into September 4th, we can see that nothing is screaming as the number one issue. However, looking at the section below the graph, here we see 3 additional tabs: Advisors, Resources, and SQL Text. If we look at the data in the Advisors tab, you can see there's a query in a critical state that has higher than normal execution. Since this is in a critical state, let's look here. This is an example of how DPA goes beyond a traditional monitoring tool that will show everything is healthy. The Advisors section has a wealth of information about this particular SQL statement, including the wait events, who was running it, and the number of executions. After looking at this detail, your next question may be, is this normal? Before going further, let's name this SQL statement something a little more meaningful that will help us to track it. Use the back arrow in your web browser or click on a link in the breadcrumb trail to navigate within DPA. With just 1 click from the trend dashboard, you can see the historical performance of this SQL statement. Next to the historical charts, there's a new Analyze Query dropdown that will invoke the Advisors feature for any SQL statement on the screen. The historical chart screen provides a deep dive of information regarding the selected SQL statement. With these graphs, we can see something is out of the ordinary. On September 4th, there were less executions, but the statement had more wait time. Another thing we can clearly see is that one wait type dominates the others, page IO latch. By clicking on the legend, we see this is a disk-related wait type, and can get advice on how to reduce the impact. We can further research disk I/O performance by going to the Storage I/O dashboard. In addition to the Read tab, you can also click on the Current View or Writes tab. In this 30-day view, the concept, much like with the Trend dashboard, is just click on the big bars and drill down to the root cause of the problem. You can hover over the bars to see the green color representing this file has much more time on the 4th than other days. We can confirm that I/O waits dominated the day by looking at this chart to compare I/O waits to other non-I/O related waits. This means we're on the right track. By clicking into September 4th, we see the distribution of the waits across the day don't vary widely. They all look to have high wait due to I/O. Since it is a little higher from 8 p.m. to 9 p.m., we'll take a look at this time frame. Once in the hour time frame, we want to select the file that seems to be having the highest weight against it. Selecting the file brings up multiple ways we can see the data. When you click on the latency comparison link, you can see the file, the average for the top files on the same drive, and the average for the top files in the same instance. To drill down further, click on the Compare to Files on Same Drive link. This breaks out the average latency that was shown in the previous graph. With this easy-to-read graph, it's clear the slowness is mainly isolated to a single file. But what is the cause? One way to know is to click on the Throughput versus Latency link to see if it's high throughput, meaning more data, or low throughput, which is an indication of something outside the database. After isolating this issue, click on the mail icon to send these graphs to the storage admin. Or better yet, give read-only access to DPA so that every user that's on the team can see the issues for themselves. Now that we have isolated this issue, let's go back to the trend dashboard and continue investigating. In another scenario, there was a complaint of slowness starting September 2nd around 11:30 a.m. The graph does show that there is a SQL statement that was taking a lot more time, or at least was more prominent starting September 2nd. Let's go ahead and name this SQL statement and drill into the second to find out more information. Since the users were concerned starting at 11:30, we will click on the 11 a.m. to 12 p.m. time range. Within the top 50 SQL statements, we see that some locking weight is present. Click the Blockers tab to find the lead blocking session and which queries were being blocked. Send this screen to developers or change management teams to note where there was blocking. For even more detail, click the Time Slice tab to view performance data down to the second. By clicking Show Baselines, hourly baseline detail is displayed for each resource metric. Click here to select additional metrics. Hovering over the highlighted portion, you can quickly determine if a resource metric is normal or not. Correlating the bars above with the resources, you can easily get a picture of the health of the database for a specific granular time frame. By clicking through these tabs, you can isolate a dimension. For example, click on the Machines tab and select the top item. Now we are seeing the top SQL filtered by the selected machine. To quickly pinpoint issues occurring now, click on the current link. Here we see what is currently running, the longest running SQL, and the most executed SQL in the last hour. Using this in conjunction with the Storage I/O Current tab allows you to get a full picture of what is contributing right now to slowness. This demo has only covered a small portion of the capabilities of DPA. There are also alerts, metrics, and reports that you can customize to track what is important and relevant to your business. Thousands of database professionals are taking advantage of DPA to improve application performance and quickly troubleshoot issues with multi-dimensional performance analysis. Whether you are an expert or not, DPA can help you quickly find the root cause of your most complex application and database performance problems and help you fix them. To learn more about how DPA can help you become a better database professional, or to download a free, fully functional trial of Database Performance Analyzer, visit SolarWinds.com.